Okay, let's go over the quiz. Let's go over the quiz. Okay, the first few we're talking about this equation of a cosine function. Right? We spent on the days, we did 1 day of the graphing, and everything we did was really focused on this. Let me take that off. Blue. Y equals D plus A. We use sine, but it's the same for cosine. Bx minus C. And just trying to describe what do those 4 letters do. And that's what these first two, that's all they're asking you for. Right? Which one of those 4 letters affects the period? A, B, C, or D? The B, okay? But the B is not the period. It's part of the formula. What's the formula for the period? 2 pi over B, right? And so this case, it's 2 pi over 2, which is 4. The pi's cancel, 2 over a half is 4. Okay. Where do you look for the amplitude? Which one of them? It's A is not the amplitude necessarily. It's the absolute value of A, right? You got to go absolute value of A is the amp. And so in our case, it's the absolute value of -8, which is 8. Right? It's not asking you max and min. It's saying amplitude. Some people are saying, oh, it goes from -8 to 8. So it's not really the question. The question is, what is the amplitude? How far is it in a positive sense, above and below the middle? Okay. Describe the vertical and horizontal shifts. Which one of those letters is the vertical shift? The D. Okay. Come on. This is the same stuff we did in Algebra 2, forever, for everything. If you add a number after the function, the up and down, plus means up. I mean, we're still struggling with this. It's clear we don't even speak the same language. +3, up 3, right? Up 3, right? So that leaves one letter that affects the horizontal shift. And which one was it? The C. But the C is not the horizontal shift. What is the horizontal shift? What's the formula? C over B. Go back and look at your notes. I probably used 20 slides going over this stuff and gave you, at every step of the way we updated that, and at the end we pulled it all together. I don't know if you're taking a quiz on 3 sections and 2 of them were what you studied for the quiz. But that was almost the entire lesson that day. The horizontal shift is C over B. Right? In our case, this is going to be the C is pi over 2. The B is pi over 2. So the horizontal shift is 1. Is it left or right? Because it's a plus inside the function, that means left. Left 1. Describe the shape of the graph. What is the shape of a cosine or a sine? It's a wave, right? I'm real clear on that. From day 1, we start talking about trig functions. It's wave, wave, wave. And we use these functions to model things that otherwise we couldn't do. I mean, even if you draw something like, some did, right? They go like that. Well, how do I know that's not a 7th degree polynomial? It has these bumps, and then it actually goes up from there and down from there. I mean, the whole importance of a sine or a cosine is that it's periodic. It's actually going to go on forever with that shape. It's not just what you see right in front of you. It goes on forever. And what kind of things can we model with sines and cosines? Well, because it's shaped like a wave, waves, you can do things that go up and down and up and down. You don't think of the temperature like that, but it is, and I'm sure I've used that before since I'm a weather guy. That's the pattern. Things that they go up and then they go down. I mean, how about the stock market? Up and down and up and down. You ever hear of dollar cost averaging? Yeah. Dollar cost averaging? I mean, dollar cost averaging basically says that if you're investing in something, and let's say it starts at one price, you invest the same amount of money every month. Let's say you're going to put in $1,000 every month, and And at one, if the price is $10 a share, how many shares do you get? 10. 10. If the price goes up, right? The price is going up. How many shares do you get when you buy? Spend $1,000. You get less, right? And then it goes back down again because that's the way the market goes. And then maybe it goes down to less than 10. How many shares do you get when you spend $1,000 and the price is less than 10? You get more than 10. And then maybe it comes back up to where it was before. And that's kind of the nature of stocks. It is kind of like a sine wave. The dollar cost averaging will tell you that even if you spend the same amount every month on these investments and the price goes up and it goes down and then it comes back to where it started again, you just made money. You will make money if that's all the stocks ever do. You're going to make money. Why? Because you bought more when it was at a low price than you did when it was at a high price. So if you take the average of that, you would have made money if that's all it's doing. Now, we really hope that that sine wave maybe is going up. You know, it's still going to go up and down, but we would hope that it's higher at the end than it is at the beginning, and you're making money. But, I mean, that's another thing you could model with sine or cosine. Does it matter which one you use, sine or cosine? Because what's the relationship between sine and cosine? One's a horizontal shift of pi over 2 than the other, right? So they're all like that. Okay, so all you had to say in this one is wave. If it says describe, use words and describe. And all you had to say was wave. Just have the word wave in there somewhere. Okay. And then these were inverses. So remember, when we take a composition of a function and its inverse, we would think that the composition cancels each other out and you get whatever's inside is the answer. But it's got to be, the domain has to be correct, right? What kind of values are we allowed to plug into the sine inverse? Between -1 and 1. Remember, the domain of the sine is all real number. The range is -1 to 1. So for the inverse, the domain is -1 to 1. You can only put in values -1 to 1. Okay, well, is pi over 4 between -1 and 1? Yeah, I mean, 3.14 divided by 4 would be less than 1. So, yeah, that is the answer. That was it. No work to do, nothing. Okay, and then these are a little bit different, right? The cosecant of the cosine inverse of -7/8. It's like asking, what is the cosecant when the cosine equals -7/8? And it even, in the homework problems in the book, it'd say, hint, draw a triangle, right? Hint, draw a triangle. So, hint, draw a triangle. Which quadrant are we going to draw a triangle in if the cosine equals -7/8? Remember, for these inverse functions, we are only looking for the cosine in quadrants 1 and 2. In which one of those is the cosine negative? In 2. So you had to draw a triangle in quadrant 2. So I would just draw something like that before you start. There's theta. Now you have to label two sides with 7 and 8 and put a minus sign where it belongs. Cosine is adjacent over hypotenuse, right? So adjacent is 7, hypotenuse is 8, and because it's to the left of the middle, that's a negative. The negative goes on that. It could never go on the hypotenuse anyways. The R is always positive. And then how do you find this? Pythagorean theorem, right? So the Pythagorean theorem would say the square root of 8 squared minus -7 squared, which is the square root of 64 minus 49, which is the square root of 15. Okay, then once you've got your triangle drawn, you can answer the question, what's the cosecant? Well, let's see. Cosecant is the flip of the sine. Sine is opposite over hypotenuse. So cosecant should be hypotenuse over opposite. So in this problem, the hypotenuse is 8. The opposite is square root of 15. And rationalize. right? So still not enough drawing of pictures. And when you do draw a picture, it's like doesn't really look anything like it ought to look like. I mean, if you're drawing, if you determine you need a triangle in the second quadrant, the picture is going to look pretty much like this. If you're drawing something over here and then labeling, I mean, it's possible you're going to get it. Maybe you'll, luck upon the right thing, but you're not, somehow don't really understand the sense of it if you're putting it anywhere else except for right there, okay? So questions on the quiz. So I have a question. How many of you are applying for National Honor Society this year, right now? How many? Raise a hand. Raise a hand. Uno, due, tre. Anybody else? Come on. So on Wednesday, when we're supposed to have our test, there's going to be an assembly for people that are doing that. And they say it's going to be 15 minutes, but it's never the time that they say it is. And so I'm kind of thinking, maybe we'll save the test for Friday. Otherwise, we have some people that aren't going to have enough time. I don't know. I mean, given the results of the quiz, which were not good, that would be more time to prepare. We'd go ahead with section 5.1. It's something easy. You wouldn't even worry about the homework. So I'm thinking that's what we'll do. We'll wait for Friday for the test because of that, right? And I thought 3, but in case it ends up being more than that, and because reacting to the quiz and that. I mean, you didn't do well on the quiz. And I think most of the things that are on there weren't that hard. I mean, they're just not. And you're going to get some things like that. So I'm going to go over I'm going to review a little bit and put up the study guide. And that'll be it. I don't think it'll take that long. So here's the first thing on the study guide is you need to know the characteristics of the graphs of the 6 trig functions, meaning, what is the shape, what is domain in the range, period, amplitude, if applicable, max and min values, asymptotes, zeros. I mean, this is the sine and the cosine. You would say the domain and the range are given right there, right? Domain is all real numbers, range -1 to 1. The period is 2 pi, right? It goes through one complete period between 0 and 2 pi and then repeats itself. We're just talking about the basic trig functions, not any coefficients or multipliers in there or anything. Cosine, again, is the same shape, so it's going to have mostly the same details as that. It's just going to be shifted pi over 2 to the left. So the shape, the domain, and the range, the period. What is the amplitude of the sine and the cosine? 1, because you don't see a number in front, it's 1. What is the max and the min? Max and min. Max is 1, min is -1. What else is on there? Asymptotes. Are there any asymptotes? No, right? Because the domain is all real numbers. You can plug anything in. Nothing is undefined. And the zeros. So we should know where the zeros of a sine function are. I mean, just think. It all goes back to the unit circle. The sine is the y coordinate, right? So the sine is 0 at 0 and pi and 2 pi, right? And every multiple of pi, there's another 0. 0 and pi and 2 pi, and it would just keep going forever. How about cosine? The zeros are, it's the x coordinate, and the x coordinate is 0 here, so it's pi over 2, 3 pi over 2, 5 pi over 2, 7 pi, it just keeps going. Every n pi plus or minus, or pi over 2 plus or minus n pi, boom, you're at another 0. So sine and cosine. Tangent. So tangent, if you look at the shape, I mean, you can see the shape. I would say that the other 4 functions aren't going to be that easy to describe, like, oh, it's shaped like a, but how about domain? Is it all real numbers? No. So you got to keep in mind, tangent equals sine over cosine, right? Tangent equals sine x over cosine x. So since we're not allowed to divide by 0, wherever the cosine x had a 0, that was pi over 2, 3 pi over 2, etc., then you got to have an asymptote. It's going to be a place on the graph that the tangent function cannot touch. Right? So it's the zeros of the denominator, which are what we just did on the last slide. How about max and min? Or how about amplitude? Oh, sorry. How about period? Actually, let me start over. So the domain is all real numbers except pi over 2 plus n pi, where n can be an integer, any integer value. The range is all real numbers. Right? This goes infinitely down, it goes infinitely up. Would it make any sense to talk about an amplitude? No. How about the period? How long does it, what's the interval of x that it repeats itself? From negative pi over 2 to pi over 2, that's pi, right? It repeats itself every pi. So you could see the period is pi. And the max and the min, would it make sense to talk about a max and a min when it actually goes to infinity and negative infinity? No. The asymptotes we already talk about when you talk about the domain, and the zeros are, again, if that fraction equals 0, it's because the numerator equals 0. So where the sine function equals 0, the tangent function equals 0. And we already said that was 0 and pi and 2 pi, etc. And the cotangent is cosine x over sine x. So basically, where the zeros and where the asymptotes are, they switch because the sine and the cosine switch. Right. These are the secant and the cosecant. This is the cosecant on the left. And again, the shape, I mean, you should kind of understand what the shape is. I thought we'd be describing it in any kind of qualitative way. But again, since the cosecant is 1 over the sine, you're dividing by something that could be 0. It's going to have asymptotes. Right? Wherever the sine equals 0, the cosecant has asymptotes. They don't show it here, but there's another one right at 0. Okay, the range is it all real numbers? Yes, where is it not? Yeah, I mean, there's no values in between -1 and 1. So if you were going to state the range, they've said it here, like negative infinity to -1 inclusive, and 1 to infinity. So it's negative infinity up to -1, +1 to positive infinity. Okay. It still doesn't take, what is the period of this thing? Yeah, I mean, the entire graph, one period includes one upward opening branch and one downward opening branch. So it's going from 0 to 2 pi, which makes sense because it's 1 over the sine, and sine was 2 pi, right? So same thing will be true for the secant. So sine, cosine, secant, cosecant, they're all 2 pi. Tangent, cotangent, pi. They're the only two. Okay. Amplitude, max, min. Wouldn't make any sense to talk. Really wouldn't, even max or min, you couldn't talk about. You could definitely talk about asymptotes. What about zeros? There are none, right? It never crosses the x-axis. Right? So the difference between this graph and this graph, just like between sine and cosine, it's a pi over 2 shift. All the other details are the same. Okay, so we need to know this y equals d plus a sine or cosine bx minus c. You know, what's the effect of those 4 letters on this? So we just went through that on the quiz, right? That's vertical shift, amplitude, period, 2 pi over b, horizontal shift, c over b. So we know how all those work. On the study guide, it says these 61 to 66 is just the A part. right? The A part says describe the sequence of transformations, meaning just describe what all the letters are doing there. It's shifted, 3 to the left, 4 up, 4 down. There's this kind of amplitude. Just know those 4. Or even these aren't bad problems. I never saw those before, but this one says, find A, B, and C for the function f of x equals a sine bx minus c. So what is the one letter they dropped out? They don't have the D in front. And what is the effect of the D? It's a vertical shift. So there is no vertical shift. You could see all 4 of these graphs are centered at y equals 0, right? They're not up or down. Okay, so how could I tell what the A is? By looking at one of these graphs. I mean, how far above the middle and below the middle is this graph going? It's going up and down. Yeah, 3. So the A is 3. And what does it look like the period is? See, this is 0 and pi and 2 pi. It doesn't quite show it, but we could definitely see one period. It started here, it went down, it went up, and then it came back again, and that was all within pi, right? So the period of this thing itself is pi. Okay, well, we need to know the b. So that's telling us if 2 pi over b equals pi, solve for b, right? Multiply times b, divide by pi, b equals 2. B equals 2. And now there could be some differences in the way you handle the next thing, but is there a shift left and right? I mean, we expect that the sign goes up first and then down. So you could consider, well, maybe then we could say that it's been shifted pi over 2 to the left. But what's another way you could make it, instead of going up first, make it go down first? You could have just made that a -3. That would have done the same thing. So we could have considered this to be a pi over 2 shift to the left, which it meant you would say c over b equals pi over 2. And we know the b is that, right? So that would make, if b is 2, then c is pi. So that could have been pi. So either you're going to have that as a +3, and that's going to be pi, or that's going to be a -3, and it'll just be bx. So you could, try to look at these, see whether you could back out what those letters must be. Okay, for the inverse functions, there's going to be, I think, 2 problems actually that are like this, where it's saying exactly evaluate these inverse functions. And all of the values you see inside there, those are unit circle coordinates. So you're expected to just answer this with your knowledge of the unit circle. For example, the arc sine of 1/2. It's saying where is it, at what angle in radians does sine equal 1/2? So I draw a unit circle. I say, okay, I know that the 1/2 always goes with √3 over 2. Which is bigger? The √3 over 2 is bigger. So we're saying that the y coordinate is less than the x coordinate. That's at pi over 6. Right? The x coordinate is that far. The y coordinate is that far. So pi over 6 is √3 over 2, 1/2. So you just answer it. You say pi over 6. How about, where is it that the tangent equals √3 over 3? Well, just think, when you start seeing things like √3 over 3, you know that a denominator got rationalized. That what it really was the tan, the arctan of 1 over the square root of 3, and then it was rationalized. Okay, well, do this. Whenever you get that kind of thing, 1 over √3 or even √3 over 1, just divide numerator and denominator by 2. And that's like saying, where is it that the sine is 1/2 and the cosine is √3 over 2? It's actually the same place. It's pi over 6. Right? You don't recognize root 3 by itself, but you should recognize square root of 3 over 2. So you need to be able, just with the unit circle, and you're not given the unit circle, you need to be able to just recall that much. And then there will be a couple, let's see, did I not put everything in there that I need? Oh, I should have had something on here which showed when is it that when you take the composition of a function and its own inverse, there's going to be two like that. Like on the problem number 4 on the quiz. Remember, it's all about domain. If it's in the domain, then that's going to be the answer. If it's not in the domain, you might have to do something to massage that. Let me see if I got that, since I didn't put it on here. Let me go back to this. Hopefully it's not, what chapter is this? 4. So this was in 4, 8, and then go back. Not that one. That's the one I did remember to cut. This is the one. Like these here at the bottom. Right, the sine of the arc sine of 0.3. Is 0.3 in the domain of the arc sine? Yeah, between -1 and 1. So the answer is 0.3. How about the tangent of the arc tangent? Is 45 in the domain of the arctan? Remember, what's the domain of the arctan? It's the same as the range of the tangent. We just saw it on the graph. Tangent goes from -infinity to +infinity. It's all real numbers. So the domain of the arctan is all real numbers. You can put anything on it. So it's 45. What about if you have something like this, where it's the arc sine of the sine of 3 pi? Could the answer be 3 pi? Remember, the range of the arc sine is -pi/2 to pi/2. So that can't be the answer. But we don't say can't do it. What we do is first try to find a coterminal angle. Maybe it'll be between -pi/2 and pi/2. So what would you do? Subtract 2 pi. Okay, and then you got the sine of pi. That's still not between -pi/2 and pi/2. But the truth is that you can evaluate the sine of 1 pi. What is the sine of 1 pi? 0. So the arc sine of 0 is in between -pi/2 and pi/2. Where does the sine equal 0? 0. So the answer is 0. So it's always a little trickier when the inverse function is on the outside and the regular function is on the inside, because you may have to play those kinds of games. If it's the inverse function on the inside, it's just a matter. Is it between -1 and 1? If it's not, you just can't do it. Okay, then back to this. So then you're also going to get like the 5th question on the test, on the quiz, where it's a composition, but they're not the same function. So you're going to have to draw the triangle. Right? The sine of the arctan of 3/4. So what is the sine when the tangent equals 3/4? Draw a triangle. Draw a triangle. And so you need to know what quadrant would you draw the triangle in if the tangent was positive. First quadrant. Okay, how about the cosine of the tan inverse of 2? What quadrant would we draw a triangle if the tangent was positive? 1, right? Remember, which quadrants do we look for tangent? 1 and 4, right? So it's positive there, it's negative there. So we draw the triangle in quadrant 1. Where's a more interesting one? Yeah, secant of the arctan of -3/5. Which quadrant is the tangent -4? So draw your triangle here, right? Remember, triangles always start there. Draw the terminal side. Theta is always with the x-axis. So there'd be a couple like that. There'd be a couple like the ones I just showed there, right? And then there'll be a couple that are like that. Okay, then there's going to be the law of sines and the law of cosines. And these problems here, if you notice, this is the 5 through 16. I didn't actually put 1, 2, 3, and 4 because those, they gave pictures. You're not going to get a picture. It is going to be more like this where it just says two angles and a side, right? So there will be at least a problem where you know two angles and one side. It's either angle, side angle, or angle, angle, side. Remember, in the end, those are pretty straightforward because if you know two angles, you always know the third angle anyway. So you just do 180 minus. So they're essentially the same situation. You need to know how to draw the triangle then. Remember, these are oblique triangles, meaning they're not right triangles. And it doesn't really matter which letters you put at which vertex. But normally the way they do it in the book, especially when we get to the side angle case, they're always putting A here, and B is here, and C is here. And then how do we label the sides? The opposite side has the lowercase letter, right? So lowercase a is here, lowercase b is here, lowercase c is there. So you're going to have to be able to do that, okay? And then, again, let's say we were going to do number 9, right? If this is 102.4 and C is 16.7 and A is 21.6, so that's angle, angle, side. Remember, for the law of sines, we need to have one side and opposite angle that we know them both. And we don't have that. No, actually, we do have that, right? We know both of these. So in the law of sines, on one side, we'd be using the A over the sine of A. And on the other, you're going to have to do C over the sine of C and solve for the C. If you had, let's say, A, C, C. I think they had one in here like A, B, C. Yeah, like this one here, number 13. A, B, C. All right, this one is A is 35, B is 65, and side C is 10. So you don't have one side and opposite angle, but because you know those two, you can find that one, 80. And now you do. And now you can solve for either one of these two that you want. So there will be something like that. One is I don't remember if it's angle, side, angle, or angle, angle, side, but it's one of those. And then I guess I didn't copy the 25. This is going to be the angle, angle, side, or angle, side, angle. Right? This is going to be the side, angle, these four. And remember, that's the one that was complicated. That's the one where you could have one triangle, you could have two triangles, or you could have no triangles. And you just have to work through it to see which one it is. I think these problems in here, there's at least one of them. I think it's the number 29, which is two triangles. And the problem on the test says, find two values for the angle. So it's going to be, you're going to be doing that. It doesn't ask you to solve the whole triangle. It just says, find two angles for this one. Okay. So anyways, law of sines, there'll be two problems. One will be from this group, and one will be like the 25 to 29. And then the law of cosines, okay, I put in 5 to 12. You're not going to get the triangle drawn on that, but I just, in order to show you that. Remember, the two scenarios that we use the law of cosines for are side, 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 and side, angle, side. Something like this one, side, angle, side. Okay. Let's say that you've got a side, angle, and a side. What do you have to solve for first? The opposite side, C, right? And then from there, you could use the law of sines if you want to finish it. What if it's side, side, side? What should you solve for first? Solve for the largest angle first. How do you know which one is the largest angle? It's across from the biggest side. So like in this number 5, you would solve for angle C first. And why do we do that? Yeah, if there is an obtuse angle, it's going to have to be across from the biggest side, right? A triangle can only have one obtuse angle, and that would be the biggest angle in the triangle. So if there is going to be an obtuse angle, find it with the law of cosines, where it's really clear, right? Because again, if you look at the unit circle, right? The cosine is positive here and it's negative there. So you know right away, based on what the value of the cosine is, whether you're in quadrant 1, acute, or quadrant 2, obtuse. But the sine has got it's positive in both of those. So you don't necessarily know. When you know the sine will be a positive number. Now you have to figure out, is that acute angle or is it that obtuse angle right there? And how do you do that? Let's say you found one of them. You said this is 45 degrees. Then you'd have to come over here and say, well, if that's 45, then this has got to be 180 minus 45. In this case, that would be 135. Well, then consider you were already given one angle. If this 135 plus the angle that you were given are more than 180, then we don't have an obtuse angle. If they're less than 180, then you might have an obtuse angle. Right, now, the 45 to 52, those are kind of like the word problems in our homework last night. I mean, that's where those come from. It's that page. We did some of these in our homework. So there'll be one like that. I think that is it. We did that one in the homework last night. So you need to know bearing. This kind of bearing. Because they have one or two we've seen where they kind of give it not as north or south degrees, east or west, but it seems like they're giving it to it, relative to a straight north line. And I think one of those problems, 45 to 52, are like that too. But the test question will be like that. Boom. Okay. So this is the study guide. Right. Know the characteristics of all the graphs. This is the inverse functions. No, this is still the characteristics of the graph. The inverse functions. I think I need to add something to that, I think. I'll check on that because we've got time. And the law of sines and the law of cosines. Know how to label a triangle with the letters. Know how to use the bearing to label an angle. And then the law of sines and law of cosines are given to you on the test. You don't have to memorize that part of it. Okay? So I would just work on that.